Our theorem for today is the last theorem in this lesson, which is theorem 12. Theorem 12. The measure of an angle between a tangent and a chord at the point of tangency is equal to the measure of the inscribed angle subtended by that chord in the alternate segment. So, to explain that more, we will draw a circle. What we need here, the measure of an angle between a tangent. So I need a tangent. Okay, this is the tangent. Of course, if I have a tangent, I have a point of tangency. Let's make it this point. This is the point of tangency. Okay, the measure of an angle between a tangent and a chord, so I need a chord at the point of tangency. So it means my chord will start from the point of tangency. Let's make it like this. Okay, this chord starts from the point of tangency till any point on this of the circle. So they are talking about which angle? They're talking about this angle. The measure of an angle between a tangent and chord at the point of tangency. Between tangent, chord at the point of tangency. So they are talking about this angle. Is equal to the measure of the inscribed angle. We need inscribed angle subtended by that chord. What does it mean? I need an angle, inscribed angle, but I don't know where exactly. Oh, they want this inscribed angle. You can make its vertex in any place, but it should be opposite to that chord that we are talking about. So this is the chord that we are talking about. This is the inscribed angle. It's opposite to that chord. Okay, so not any inscribed angle. We need the inscribed angle which is opposite to that chord. So this is the angle they're talking about. That said, the angle between the chord and the tangent at the point of tangency is the same with the angle, with the inscribed angle which is opposite to that chord. Now they want me to prove this. Okay, to make it easier, we should give them names. Let's make this one A, B, and C here. And of course, I will give the letter O as an A in the circle. This is D, and let's make this one F. Also, to make it more easier, using numbers is better than letters in this. So I'll give this one, this angle, the name 1. This is the first angle, and this is, I will give it number 2. So now we want to prove that the measure of angle number 1 is the same with the measure angle 2. This is what we want to prove. First of all, we need givens. What is my givens here? We have a circle, O, AC, the tangent. It's tangent of this circle at what? At B. So P is the tangency. And we have BF is a chord. BF is the chord. BDF. BDF is what? Is inscribed angle. This is what we need. We need tangent, chord, inscribed angle. This is the given. What they want me to prove, as we said, we want to prove that measure of angle 1 is equal to the measure of angle 2. This one is the same with this. So in this theorem, we need to make something to prove that. So we need construction. What I will do, I will start from B. and I will make diameter to any point. Okay, here it should pass the center, and I will join D with this point, the new point, and I will do F with that point. So we need to give it a name, which is E. Okay, so this is the construction. Sorry. I will change here to show you that we just make them ourselves. Those 3 lines, we make them. It's not from the theorem itself. Okay, and I have here an angle, and that one is angle. I will give that one the number 3, and this one number 4. So this is my construction. We have 3 lines, BE. We draw from B to E, from D to E, from F to E. Now the proof. The proof is too easy. As we see here, we have 1 and 3 together. They're beside each other. So this angle, all of it, 1 and 3, both of them, is 90. Why? It's theorem. I have here from O to B, it's what? It's radius. It's radius. Radius and tangent, the angle between them is what? Is 90 degrees. So this is a right angle. So the measure of angle 1 plus the measure of angle 2 equals 90. This is the first thing. As we know, OB is perpendicular to AO. OB is perpendicular to AC. It means this is 90 according to the theorem. So measure of angle 1 plus the measure of angle 2 equals 90. Number 2, the second thing here, measure of angle 2 plus the measure of the angle 4 is also 90. Why? 2 plus 4 is 90. This angle, it's inscribed angle, all of it is 90. Why? Because it's drawn in a semicircle. This is diameter, so it's drawn in a diameter, and we take this theorem before that if I have inscribed angle in a semicircle is a right angle. So the measure of angle 2 plus the measure of angle 4 is how much it is? It's 90 according to theorem. So 3 plus 4 is 90. Now I have those both are 90. Those both are 90. So it means those both the same with those angles. 1 plus 3 is the same with 2 plus 4. I mean the angle. Angle 1 plus angle 3 equal angle 2 plus angle 4. Okay, because we compare between them. This is 90 and this is 90. That means they are equal. What else? I want to prove that. I want angle 1 equals angle 2. What I will do, as you see here, what's the relation between angle 4 and angle 3? What's the relation between them? Angle 3, as we see, it's inscribed angle. Angle 4, it's inscribed angle. The arc of angle 3 is what? Is F and E. So FE is the arc. The arc of angle 4 is what? Also it's E and F. So they have the same arc. What does it mean? It means the angle 3 and angle 4 are equal because they have the same arc according to what? According to theorem. So cos 2 equals 4. The measure of the angle 2 equals the measure of the angle 4. So go up here. We said 2 the same with 4. So they will cancel each other. So this one, because it's in the left side, will go with this one because it's in the right side. They are the same. So I will cancel measure of the angle 2 with the measure of the angle 4 together. So still for me what? Only 1 and 2. So the measure of the angle 1 equals the measure of the angle 2. So we did prove it.